Welcome back to my YouTube channel Liang Crackers for cracking IIT and NEET. So today in this video we are going to discuss about homologous series, and don't be late, let's start. Homologous series. Homologous series. So what is the definition of homologous series? A series of compounds where each compound differs from the next compound by a constant unit CH2, a molar mass 14 grams. So what is the definition? A series of compounds where each compound differs from the next compound by a constant unit CH2 or molar mass 14 grams. And this is the definition of homologous series. And the members of the homologous series are called homologs. And there are three important conditions to say homologous series. So what are those? Let's see. The first condition is it should contain, that means the two members should contain same chemical properties. And the second condition, the two members should have different physical properties. And the third one is between two consecutive members, the difference is CH2. Of course you can say 14 grams molar mass difference. And one important trick here, remember, this third condition will alone never explain about homologous series, but the condition along with other two conditions will explain the homologous series. Let's see how to distinguish these two things. If we take alkane, normal general molecular formula of alkane is CnH2n plus 2. If we take first CH4 and second one is C2H6 ethane, the third one is C3H8, right? This third condition, what is the third condition? Between two consecutive members, so means adjacent, are where each compound differs from the next compound. This compound differs from the next compound by a constant unit CH2. If we check the constant unit CH2 we are getting, and here to here a consecutive members, the difference is also here CH2, right? And this condition is satisfied, but this condition alone will never explain about this homologous series. This along with two conditions will explain. Now, so first the third condition is satisfied, CH2 difference between these two members, and we should check these two conditions also. Then only we can say these two are homologs, or else these two are not homologs. Okay. And the same chemical properties. This is alkane and this is also alkane. So these two are undergoing same chemical properties like free radical reactions, and this differ by physical properties. And of course here to here molar mass increases, then automatically van der Waals attraction forces are increased. So either different in melting or boiling points are there. So three conditions are satisfied. That's why these two members are called homologs. Here also these two members are called homologs because these two are belonging to these three different conditions. And if we take alkene, another example, alkene. So what is the general molecular formula? CnH2n, the first member. So here only one carbon, we should not find that alkene. So it requires at least two carbons. So C2H4, next C3H6, next C4H8. If you check here to here, difference is CH2 and same category, so means it should contain same chemical properties and different physical properties. Here to here also CH2 difference is there. Sorry, here to here not. And yes, consecutive members. So second compound, third compound, so CH2 difference. And another important thing. Okay, so if we check 1, 2, 3, and the difference is not CH2. The difference is not CH2, but we can say these two are also belonging to same homologous series. Then what is the condition? 2 consecutive. So these two are not consecutive. If these two are consecutive, so it should contain differences CH2, but these two are not consecutive members, so this is not applicable. CH2 is not applicable, but we can say here this is the first member of homologous series, this is the second member of homologous series, this is the third member of this homologous series. In the same manner here also, it is the first member, second member, third member. So here to here, if you want to check here to here, these two are also belonging to same homologous series. There is no difference of CH2, but these two are not consecutive members. So this is the first member, this is the third member. So always we should not focus on this one, but we have to focus the difference between two consecutive members CH2 along with these two conditions. These two conditions are very, very important. The two conditions are very, very important. Now, let's say with another example, so why it is not homologous series and why these are not homologs. So methanamine CH3NH2, this is the first compound, and the second compound is CH3CH2NH2 ethanamine, and third compound is dimethylamine. This is the third compound. If we check 1 and 2, so 1 and 2, the difference is what? We are getting same difference is CH2. So okay, between two consecutive members, the difference is CH2. So third condition is satisfied, but we should focus on these two conditions. So it is a primary amine. It is also primary amine. So primary amine, these two are having same chemical properties, and by increasing molar mass, so different physical properties are there. Three conditions are satisfied. So we can say 1 and 2 compounds are homologs. And what about 1 and 3? What about 1 and 3? This is very, very important. So 1 and 3 here also, here to here difference is CH2. But what is the amine degree here? Primary. What is the amine degree here? Secondary. So primary to secondary, different chemical properties like carbalamine test, mustard oil test in amine compounds, nitrogen compounds. So these two compounds are having different chemical properties. So that's why these two are not belonging to homologous series. So not homologs. These two are not homologs. Right? Let us take another example. So first one is a phenol, aromatic alcohol. The second one is benzyl alcohol. Second one is benzyl alcohol. Third one is either ortho or meta or para methyl phenol. Right. So here to here difference is CH2. Next, here to here difference is also CH2. So third condition is satisfied between two consecutive members. The difference between two consecutive members, unit volume is CH2 difference is there. Right. But here to here, this is what? It is an aromatic alcohol. This one is an aliphatic alcohol. Aromatic, aliphatic. These two are having different chemical properties. So different chemical properties. These two are not homologs. But it is aromatic alcohol. Here also aromatic alcohol. And by increasing molar mass, so physical properties are different. And here difference is CH2. So all the three conditions are satisfied. That's why these two members are homologs. These two members are homologs. Suppose in the descriptive manner, if we say C3H6O, so we have to draw few structures of regarding this molecular formula. Let's check. And here for these kind of questions we have to find first du. Like shortcut is shortcut. What is a du? Oxygen is neglected. So what is a du? 3 plus 1 4. minus 6 upon 2 3. So we are getting what is the du? 1. Du is 1, and here 3 carbons are there. So based on this one I am drawing one structure, 3 carbons, 1 oxygen with du1, right? And we are not discussing about du here, isomers. We are discussing about what? Homologous series. Homologous series means if one carbon is there, next compound should have one extra carbon, means extra carbon. Here 3 carbons are there, so I am drawing now with 4 carbons with the same du. If du is same and number of carbon difference is 1, then we can say these two are the difference between two molecular mass. A molecular formula is CH2. We can say indirectly. So if you want to find here what is the formula, this one C3H6O, right? Here 2 hydrogen, 2 hydrogen. So number of carbons are 4, hydrogens are 8, and oxygen is 1. So what is the difference here we are getting? We are getting CH2 difference. So what is shortcut? How du will help you here? If du is same and the difference between two consecutive number carbons is 1, then automatically, so unit difference is CH2 we can get, right? Another same here, this is a 3-membered carbon. I am drawing with the 4-membered carbon, 1 oxygen atom. See, 3 to 4 carbons, du1, here also du1, means the difference between these two is also CH2. The difference between these two also CH2. But what about chemical properties? This is what heterocyclic compound or cyclic ethers. It is also cyclic ether. It is also cyclic ether. The difference between these two CH2 and same chemical properties are there. So we can say these two members are homologs. And here to here, if we check, here also same 3-membered carbon, 4-membered carbon. Difference is CH2, but this is a cyclic and this is unsaturated alcohol. So these two are having different chemical properties. That's why these two are not homologs. These two are not homologs. Like du will help you to find homologs also in the descriptive manner type of questions. Okay, and this is overall about homologous series. So we will discuss in the next video with another important trick. Thank you so much.